So briefly, with this question, we're given the velocity vector v, and we're told that this particle is at the point A when t equals 1 and at point B as well when t equals 4. And so we've got to find the exact distance AB. Now, in order to do this, I'm just going to sketch out the method I'm going to use in case you're stuck and you want to pause the video and carry on. What I'm going to do is first of all work out generally where the position vector of the particle is. That's just going to be given by r, and I can get r by integrating the velocity v with respect to t. So we'll do that, get an equation for r. Then I'm going to work out where it is when t equals 1, just by substituting t equals 1 into our final result here. And I'll do the same when t equals 4, and I'll call those position vectors RA and RB respectively. So the distance AB is going to be given by the modulus of the position vector B minus the position vector of A. I mean, you could do the position vector of A minus the position vector of B if you liked, okay? It will still give you the same result. But really, if you're going from one place, let's say from here, that's A, okay, that's RA, and you're going to another point B, okay, that's the position vector RB, then the vector AB is given by RB minus RA, okay? And so we're just going to take the modulus of that to get that distance AB. Okay, so hope that's given you an idea of the method. Right, so let's start then. We're going to find the position vector r in general. That's going to be equal to the integral then of v with respect to t. So substituting our values for v in, we've got t to the power minus a half in the I direction, minus 4t in the j direction. Got a couple of terms here, so put that in brackets, and we're integrating with respect to t. And in the usual way, if you integrate this, t to the minus a half, just add 1 to the power, t to the half then, and divide by the half. And when it comes to, oh, that'd be an I there. And when it comes to minus 4t, that's going to be minus 4 t squared, add 1 to the power and divide by the new power, and that's going to be the vector j. Now this is a point you mustn't forget. Don't forget you've got a constant of integration, and it's a vector, so I'm just going to underline it, call it c. If we tidy this up, what we've got then is timesing top and bottom here by 2 gives you 2t to the power a half, and that's in the I direction, and here the 4 divided by 2, well, that's going to be 2. So you've got 2t squared j, okay, plus the constant of integration at vector c, okay. So now I'm just going to get the position vectors RB and RA, okay. I'll remove this, okay, so we'll just come down here now, and I'm going to get RA, that's when t equals 1. Okay, when t equals 1, we know r will equal RA. All right, I've just defined that myself for that part. So therefore, we've got RA will equal, and if we substitute the t equals 1 in here, we've got the square root of 1, which is 1, times the 2, which is 2, so you're going to get 2i there. And here you're going to get 2 times 1 squared, well, that's just going to give you minus the 2j there, and you've got your constant of integration plus c. Now I'm going to not ignore the plus c, but you'll see what happens in a moment. I'm going to look at the next case, that's at b when t equals 4. So we'll just put a note in here. We've got that when t equals 4, the particle is at what I'm going to define as RB. Okay, it's at B. And therefore, if I do much the same, substitute into here, we're going to get RB equals, and putting the 4 in, square root of 4 is 2, so you're going to get 2 times 2, so that's 4i. And then you've got 4 squared, 16, times that minus 2, that's going to give me minus 32. So that's minus 32j, and we're going to have the same constant of integration plus c. Now what I'm going to do next, remember, is we're going to work out what RB minus RA was. Okay, so therefore, if we do RB minus RA, then you see that these two constants C will cancel one another out. So if you do that, 4i minus 2i, that's going to give you 2i, and minus 32j minus minus 2j comes out at minus 30j. And we need to get that distance AB, and we know that that distance AB is equal to the modulus of RB minus RA. So that's going to be equal to the square root then of the sum of the squares of these two components. So that's 2 squared plus the 30 squared. Work that out, you've got 4 plus 900, so that's the root then of 904. And we've got to give the exact answer, and so you can actually, well, you could leave it like that, I suppose, but this actually breaks down to 4 times 226. And using the multiplication rule for surds, we can then just square root the 4, which is 2. Can't square root exactly 226, so we just leave it as the root of 226. And the units are in meters. Okay, so there's our answer. And I hope you've been able to see your way through that, okay, if it was causing any problems.